Hi students, welcome to today's class. So today also I am going to explain previous problems which were given in JEE mains examination. Okay, so let us start our class. So this was the problem given in 2018 JEE mains examinations for 4 marks. Let us see the problem. F of x is equal to x square plus 1 by x square and g of x is equal to x minus 1 by x. X belongs to set of real numbers except minus 1, 0, 1. Okay, clear? There are two functions are given. So another function is there, that is h of x is equal to f of x by g of x. This is a rational function. F of x by g of x. Then the local minimum value of h of x is. What is the local minimum value of h of x is? So 2 root 2 na, 3 na, minus 3 na, minus 2 root 2 na. Let us check the problem. The first thing is question is very clear. The question is very clear. Why? Because here f of x given, g of x is given, h of x is also a rational function, that is f of x by g of x. Then we have to find out the local minimum value. Okay, let us proceed the problem. So first of all, what is your h of x? So here h of x is equal to x square plus 1 by x square by x minus 1 by x. Then how to write this as a, let us write this x square plus 1 by x square as x minus 1 by x whole square plus 2. Can I write it as like this? Yes, I can write. Why? A square plus b square minus 2ab. Minus 2ab means minus 2 will come. Minus 2 plus 2 will get cancelled, divided by x minus 1 by x. Okay, now, so I will separate x minus 1 by x in both the terms. So I will get x minus 1 by x plus 2 times x minus 1 by x plus 2 by x minus 1 by x. Clear? So our h of x is, this is the function. Okay, this is the function. Now we have to find out the local minimum value of this x minus 1 by x plus 2 by x minus 1 by x. Okay, now then how to proceed? So up to that what we got here, x square, though x square terms will be avoided. Okay, right. Now to do this problem, so let us say that let z is equal to x minus 1 by x, so that I want so that the problem will become reduced. So therefore your h of x will become, so z plus 2 by z. Z plus 2 by z. Here z value cannot be equal to 0. Why? Because so whatever may be the value you substitute here. See here, x belongs to set of real numbers minus 1, 0, 1. X is not taking 1. So if here x is equal to 1, then what happens? 1 minus 1 by 1. Therefore 1 minus 1, 0. So z is equal to 0. Therefore z cannot be equal to 0. Therefore either z, so that means z cannot be equal to 0. So let us say z may be greater than 0, may be less than 0. So there are two cases arises. What is that? Let z is greater than 0. Let us check z is greater than 0. Another case is let z is less than 0. Let us say the two cases. Z cannot be equal to 0. Why? Because x is not equal to 1. Okay. Now if z greater than 0, let us see what happens. So this z plus 2 by z, z plus 2 by z, this can be, what is the, this can be written as, you can find out this derivative. So without derivative also, actually you have to find out this derivative. Without derivative also you can do this problem. So let us see here. So you can write down it as a root z minus root of 2 by z whole square plus 2 root 2. Can I write it as, see here, a square plus b square, this will come, minus 2ab, that means minus root z will come, minus 2 root 2, plus root 2 will, minus 2 root 2 plus root 2 will get cancelled. Okay, if you observe, this value definitely root z minus root of 2 by z whole square, either it is 0 or more than 0, that is sure. This value, whatever be this value, either it is 0 or more than 0. That means this value is always greater than or equal to 2 root 2. It is always, this value is greater than or equal to 2 root 2. Okay. So, therefore, 2 root 2 or more than 2 root 2. Therefore, 2 root 2 will be the local minimum. So, local minimum value is equal to how much? 2 root 2. Local minimum value is 2 root 2. Let us check what happens when z is less than 0, right. So, therefore, h of x is equal to z is less than 0 means what? Let us check right like this, minus of minus z minus 2 by z. Can I write it as? So, this expression z plus 2 by z. Why? Because here z is less than 0. Can I write it? Yes, I can write. So, this is equal to minus of. This also can be written as root of this minus z minus 2 root z. This can be written as minus z root of minus z. Sorry, root of minus z minus plus root of 2 by z whole square. Then check what happens, a square. Okay. Here minus have to come. Why? Because minus b square, and here minus 2ab. Already minus is there, plus should become. That means you have to write down minus 2 root 2. Check both expressions are same. You check it here. Once again I am telling. Here see here z is negative. That means minus z is positive. This expression can be written as like this. So, this can be written as a minus b whole square. A square means root of minus z whole square means minus z. My plus b here my a square plus b square will come. Plus b square means here already minus is there. Minus will come. Minus 2 root 2. So, this value is less than or equal to 0. That whatever may be the value. Why? Because, sorry, less than or equal to 2 root 2. This value is less than or equal to minus 2 root 2, whatever may be that value. Why? Because this is something 0 and this will something negative value. We are still subtracting from minus 2 root 2. Therefore, this value this should be less than or equal to minus 2 root 2. Okay. Therefore, what is the local maxima value is equal to minus 2 root 2. Okay. So, what is the local maxima is minus 2 root 2 and local minimum is equal to 2 root 2. So, therefore, he is asked to find out the local minimum value. The local minimum value of the given expression, given function is 2 root 2. Okay, na? So, very nice problem this is. Here if you observe without doing any differentiation also we did. So, if you did not get this idea, that means writing this in this form. In this form, you can do the by doing the z of z. So, that is h z of z is equal to for z derivative 1 minus 2 by z square. 1 by z derivative minus 1 by z square. That is equal to 0. So, this becomes 2 by z square is equal to 1, z square is equal to that is equal to 2. Therefore, z is equal to root 2. Z is equal to 2 root 2, like that you can do this problem. So, again you have to z at z is equal to root 2, that may be positive and may be negative. Substitute z is equal to root 2 here. So, this is root 2 plus 2 by root 2. 2 by root 2 means root 2, 2 root 2, 2 root 2, that is 2 root 2 you will get local minimum value. Like that using differentiation also you can do. So, if you have the idea writing this expression in this form, like that also you can do. Okay, na? So, I hope that you understand this solution. So, let us go for next problem. So, welcome to the second problem. The second problem is the function f from 0 to 3 to 1 to 29. That is domain is 0, 3 and the codomain is 1, 29. Defined by the function f of x is equal to 2x cube minus 15x square plus 36 plus 1 is, what is that function? So, it is a 1 onto function but not 1 function. So, 1 but not onto function. Neither 1 nor onto function. Okay, let us check this. First of all, we will start the solution. So, first to find out, even though it appears to be a problem from functions, then but we have to do the differentiation. Let us check it. First, what is the derivative of this function? First derivative, so this is a 6x square minus 30x plus 36. That means I am going to draw the graph of this function. Okay, so by seeing the graph, I will get a conclusion. Okay, right. Then how to draw the graph means in this interval 0 to 3, where it is increasing and where it is decreasing. If I have an idea, then the problem, deciding either it is a 1, 1 or onto will become very easy. Okay, so I am going to draw the graph from between the interval 0 to 3. Okay, so for that we required first derivative of this function f dash of x is equal to 6x square minus 30x plus 36. From this, can I take 6 common outside? 6 into x square minus 5x plus 6. As everybody knows, 6 into this is x minus 2 into x minus 3. Okay, now, right. Let us see the f dash of x means what? Slope of this tangents of these curves. F dash of means this have some curves, I don't know, but the slope of this is this. The slope of the tangents is equal to this 6 times x minus 2 x minus 3. So let us see the sign scheme. From here the critical points are 2 and 3, here plus minus plus. So our interval is from 0 to 2. See here, from 0 to 2 the function is increasing. Why? Because f dash of x is greater than 0. From 2 to 3 the function is decreasing. Why? Because f dash of x is less than 0. That means I can draw the graph of this function like this. From 0 to we are required only from 0 to 3 only. After 3 also it is increasing. So let us omit this. Let us omit this. In the interval 0 to 3. Why? Because our domain is from 0 to 3. From 0 to 2 the function is increasing. That means why? Because that means increasing means this. Okay, now from 2 to 3 the function is decreasing. So this is the function graph of this function. F of x is equal to 2x cube minus 15x square plus 36 plus 1 in the interval 0 to 3. Why it is decreasing? Why it is increasing? I already explained about sign scheme. That means if I draw a tangent here, if you draw a tangent here, if you draw a tangent here, it will make an acute angle with the x-axis. So if you draw a tangent here, it will make an obtuse angle with the x-axis. So this is increasing and decreasing. Now your graph of this function from 0 to 3 is. Now let us check whether it is a 1, 1 function or onto function. Clearly it is not a 1, 1 function. Why? Because for example, if you see this, it is if you observe this horizontal line test, horizontal lines. If you draw any line horizontally with horizontal with x-axis, it is intersecting the curve at 2 points. Therefore, it is not a 1, 1 function. But it is very clear. For this value, the image is this, and for this value is also, for example, if x is equal to a, the image is some 5. If it x is equal to some 2, the image is also same. For both the things, same image you are getting. For 2 elements, you are getting the same image. Therefore, it is not 1, 1. Not 1, 1 function. Not 1, 1 function means either your option may be 2, may be 4. So 1, 1, 1, 1. So these you can reduce. So it is not a 1, 1 function. To check the onto nature, so onto nature means what? Codomain should be equal to range. Here at 2 is equal to, this is a critical point, or we can take a stationary point. Okay, it is a stationary point. Substitute these values. First you substitute f of 0. At 0 you substitute f of 0 is equal to 1. F of 2 is equal to, substitute 2 cube 8, 2 square 4. Here 2 if you substitute, the value is 29. Okay, if you substitute 3, the value is 28. Okay, 28. So what is the range? Range is equal to 1 to 29. So if you observe, so you calculate this. I already calculated. So for to save the time, I am explaining this. Okay. So f of 2 is equal to 29. So what is the range? 1 comma 29. Here what is the codomain? 1 comma 29, closed bracket. That means range is equal to codomain. Therefore the function is onto function. So here onto but not 1, 1. This is your answer. This will be cancelled. Okay. So, option 2 is the right answer. So, very, very nice problem. So, what to decide this function is either 1, 1 or onto. I am trying to draw the graph in the interval 0 to 3. Okay, now in the interval 0 to 3, right. So, you may don't get that it is a 3. So, that means here it is maybe like this. Maybe like this. That means here it is 28. Here it is. This is a 28. This is 29. So, f of 2 it is 29. At 3 it is 28. At 0 it is 1. Like this. So, this is this graph will be like this. Your graph will be like this. Okay, now, right. So, I hope that you understand this solution. Let us go for next problem. Welcome to this problem. The problem is the number of points in minus infinity to plus infinity. That means in the set of real numbers. In the set of real numbers for which x square minus x sin x minus cos x is equal to 0 is. So, this was asked in JEE advanced problem 2013 in single option, correct. Okay, that those problems are also I am explaining for you, right. The thing is you have to search the number of points from the set of real numbers, so that if you substitute here, so the value should be equal to 0. This type of problems can be done using graph. Okay, na? So, if you want to draw the graph, that is where it is maximum, where it is minimum, what is the curve nature. So, you have to use the differentiation. Okay. So, let us consider the function f of x is equal to this function, that is equal to x square minus x sin x minus cos x. Okay. So, for maximum or minimum where it is taking turnings, we have to find out the first derivative. So, what is the first derivative? F dash of x is equal to x square derivative is 2x minus x sin x derivative. So, this is equal to x cos x plus sin x minus cos x derivative minus sin x, already minus is there, plus sin x. So, ultimately what is your f dash of x is equal to 2x minus x cos x. Why? Because minus sin x plus gets cancelled. So, this is equal to, for maxima or minima, f dash of x is equal to 0. So, there it takes the, if you want to check the critical points, there we have to make it into 0. So, take x common, you can take x common, 2 minus cos x is equal to 0. So, either x is equal to 0 or 2 minus cos x is equal to 0. It cannot be happened. It cannot be happened. Why? Because 2 minus cos x value cannot be happened. Why? Because this cos x value lies between minus 1 to 1. The cos x value, maximum value is 1. Cos x maximum value is 1. If you take 1, 2 minus 1, it is 1. It cannot be equal to 0. But it is greater than 0. Actually speaking, it is greater than 0. 2 minus cos x value is always greater than 0. So, at x is equal to 0, at x is equal to 0, the function may have maximum or minimum. Okay. To check that, we have to go for second derivative test. Okay, what is the second derivative test? F double dash of x is equal to 2x derivative is 2 minus x cos x derivative. So, x into cos x derivative minus sin x plus cos x into x derivative 1. So, substitute x is equal to 0 here. If you substitute x is equal to 0, what happens? Either it is a positive or negative. Let us see here. If you substitute here, it will become 0. This is cos 0 is equal to 1. So, this is equal to minus 1. 2 minus 1, 1. It is greater than 0. Okay, now, therefore, at x is equal to 0, the function f of x is minimum. It has minimum value at x is equal to 0. At x is equal to 0, what is the value here? See here, at f of 0 is equal to how much here? 0, 0, sin 0, 0, minus cos 0, minus 1, minus 1. So, if you observe the, if you take the graph here, so this is a y axis and it is x axis. At 0, the function is taking minus 1. At 0, the function is taking minus 1, that is the minimum value. It is a minimum value. Minus 1 is the minimum value at x is equal to 0. Right. Now, if you observe, as x tends to infinity, as x value tends to infinity, that means as a limit x tends to infinity, this f of x is also, value is also infinity as x approaches to plus infinity, as to be strongly speaking plus infinity. That means as x value increases, this your f of x value also increases. If limit x tends to minus infinity, f of x is also plus infinity. That means if x approaches to plus infinity, your f of x is also increasing. If approaches to minus infinity, f of x is also increasing. That means your graph will be like this. As x tends to infinity, your f of x also tends to increases. As x tends to minus infinity, your f of x is also increasing. Increasing means top. Okay, na? Therefore, your graph of this function x square minus x sin x minus cos x, the graph of x function should be like this. Therefore, this graph intersects the x axis at how many points? 2 points. It intersects the graph at how many points? 2 points. Therefore, this the number of points in which for which this function is equal to 0 are how many points? 2 points. Therefore, option C is the right answer. Okay, right. So here the thing is, up to that everybody catch the point. These 2 points are very important. As x value tends to infinity, f of plus infinity, f of x also tends to plus infinity. If as x tends to minus infinity, f of x also tends to plus infinity. So both are increasing. Okay. So if you observe these 2 points, the problem will be very, very easy. Okay. So let us go for next problem. So let us see this next problem. If f is a function from set of real numbers to real numbers, that is a set of domain is set of real numbers, codomain is also set of real numbers, is a twice differentiable function. That means we can differentiate, we don't know that function is not given, it is a twice differentiable function. That means we can find out the derivatives 2 times. Both the derivatives exist, and moreover f double dash of x is greater than 0 for all x belongs to real numbers. So what is the, whatever may be the domain, here you take that x element, if you substitute in the second derivative, it is greater than 0. Okay, and one more thing is given, f of 1 by 2 is equal to 1 by 2. That means 1 by 2 image is 1 by 2, 1 image is 1. Then which of the following options will be correct? That means f dash of 1 value lies between 1 by 2, f dash of 1 value lies less than or equal to 0, f dash of 1 is greater than 1, 1 by 2 less than, f dash of 1 less than or equal to 1. So what is the options? Okay. So let us see here. So to do this type of problems, we use one good theorem, that is Lagranges mean value theorem. Lagranges mean value theorem. What is this Lagranges mean value theorem? Briefly I will explain. So this is x axis and y axis. There is an interval a and b. In this interval, the function is, first condition is, the function is differentiable in the, continuous in open bracket, continuous. Second condition is differentiable in open bracket a comma b. Then there exists a number c belongs to a comma b such that f dash of c is equal to f of b minus f of a by b minus a. Of course, where b is not equal to a. That means what? There is a function here. So here it is f of a and it is f of b. F of a and f of b. He is saying there exists a number c belongs to a comma b. So there is actually belongs to c belongs to open bracket a comma b such that f dash of c. So that means what? If you draw a tangent here, if you draw a tangent at a C, this is a tangent. If I draw a tangent at a C, that means f dash of C. What is the slope of that? What is the slope of that f dash of C? That is equal to f of b minus f of a by b minus a. That means what? You join these 2 points here. You join these 2 points here. What is this point here? A comma f of a. What are the coordinates of this? B comma f of b. Okay now? What is the slope of the line joining these endpoints? y2 minus y1 by x2 minus x1. f of b minus f of a by b minus a. That means you can, there is just a point C such that you can draw a tangent parallel to these endpoints A, B. Okay, na? So that is the Lagrange's mean value theorem. Right. So using this here, here you see here f of 1 by 2 is equal to 1 by 2, f of 1 is equal to 1. So we can find out a number C, C belongs to 1 by 2 to 1 open bracket such that f dash of C. Why? Because he is saying that in this interval it is a twice differentiable. 2 times it is differentiable means it is continuous. It is continuous. Therefore, f dash of C is equal to f of 1 minus f of 1 by 2 by 1 minus 1 by 2. So this is A, this is B. f of B minus f of A by B minus A. So that is equal to f dash of C is equal to f of 1 value is given how much? 1 is given. F of 1 by 2 value 1 by 2 is given by 1 minus 1 by 2 1 by 2. So 1 minus 1 by 2. So this is 1 by 2 by 1 by 2 1. So f dash of C is equal to 1. Let us see that. But here you observe here. Observe, take this f double dash of x is equal to 0. F double dash of x is greater than 0 means what? F dash of x is an increasing function. Is an increasing function. If f is an increasing function, then f dash of x is greater than 0. Vice versa. That means if f double dash of x is greater than 0, that means f dash of x is an increasing function. Increasing function means what? So for this, whatever may be the given condition, from 1 by 2 to 1 by 2 1, this is an increasing function. That means f dash of C should be greater than 1. Whatever may be all the values, whatever may be the values you substitute, here what f dash of x is greater than 0. Whatever may be the x value you get, that f dash of x should be greater than 0. F dash of x should be greater than 1. That is equal to option 3 is the right answer. Okay, now. So this type of problems can be done using Lagrange's mean value theorem. Okay. So once again I am telling, don't think that f dash of C is equal to 1. That means there exists a number such that, so for all C banks, whatever may be the value, you take f dash of x C, f dash of 1, see here, f dash of 1, whatever may be the value, you take f dash of 1 greater than 1. If you take x is equal to 1, here C is equal to 1, it is greater than 1. Okay, na? Right. I hope that you understand this solution. So let us go for next problem. So welcome to this type of problem. This is a statement type of problems. This type of problems are also occasionally giving in JEE mains examination. So here, see here. Let f is a function from R to R be a continuous function defined by f of x is equal to 1 by e power x plus 2 times e power minus x. Then there are two statements are given. What are the two statements? Means f of C is equal to 1 by 3 for some C belongs to R. And one more thing is 0 less than f of x is less than or equal to 1 by 2 root 2 for all x belongs to R, he is saying. That means this is the minimum value and it is the maximum value, we have to say. So that means whenever it is given f of x 0 less than f of x less than or equal to 1 by 2 root 2 means you have to find out the minimum value and the maximum value. For that we have to differentiate the given function. Okay, now. So here the options are, already we know the options are here. Both statements are right. First statement is true, second statement is false. Second statement is the correct explanation of first statement. All those things will be there. Already you know, I didn't write those things. Okay. Now let us check whether these statements are right or wrong. Okay. So here, whenever it is given like this, you have to find out the maximum and minimum value. So see, the given function is f of x is equal to, before finding the first derivative, let us simplify this. So e power minus x means 1 by e power x. Again e power x will be in the numerator. So this is e power 2x plus 2. Okay, now find the first derivative. Okay, f dash of x. Find the first derivative and you make it into 0. Okay, so you calculate this. I already calculated. I got the answer. E power x is equal to 0 or e power. So in this e power x, you will get a quadratic equation type. So if you do the factors, e power x is equal to 0 or e power x is equal to root 2. These are the two values you will get. Is equal to 0 and e power x is equal to 2 root 2. Okay. Again you find out the f double dash of x. So at e power x is equal to 0, f double dash of x is less than 0 at x e power x is equal to 0. E power x is equal to 0, f double dash of x is less than 0. Let us try to calculate, take it as a homework. So therefore at e power x is equal to 0, f of x has maximum value. Okay, now then how to find out the maximum value? Wherever e power x is there, substitute 0. Then what you will get here? So f of x is equal to, so wherever e power x is there, substitute. So here what is the e power x is equal to? At e power x is equal to root 2. Sorry, I am sorry. So the e power x is equal to root 2. F double dash of x is less than 0. Okay, at e power x is equal to root 2, f double dash of x is less than 0. Then how to find out that maximum value? So wherever e power x is there, substitute root 2. So this is a root 2. This is a root 2 whole square, e power 2x, no, e power x whole square, root 2 whole square, 2 plus 2, that is root 2 by 4. Root 2 by 4 means here we can write it as 1 by 2 root 2. Okay, now, right. If you substitute e power x is equal to 0, so this is a 0 by 0 plus 2, this is 0. That is a minimum value. Therefore, we have, so this is maximum value, minimum value is equal to 0. At e power x is equal to 0, we will get f double dash of x is greater than 0. At e power x is equal to root 2, you will get f double dash of x is less than 0. Okay, na? So try to calculate this. Therefore, on the whole, what you will get? 0 less than f of x less than 1 by 2 root 2. So this is the minimum value and it will be the maximum value. Okay. So the statement 1 is correct. Let us coming to f of c is equal to 1 by 3 for some c belongs to R. If you observe here, this 1 by 3 value lies between from 0 to 1 by 2 root 2. See here, 0 less than 1 by 3 less than 1 by 2 root 2. 1 by 3 value lies between 0 and 1 by 2 root 2. Therefore, f of c is equal to, definitely f of c is equal to 1 by 3 for some c belongs to R. For some c belongs to R. If you take any number, f of c, x value, any number, c is equal to f, any number, definitely you will get 1 by 3 as the image. 1 by 3 as the image. Why? Because this 1 by 3 lies between 0 to 1 by 2 root 2. This 1 by 3 lies between 0 to 1 by 2 root 2. For some c belongs to R, any number, you take any number in the domain, definitely you will get 1 by 3 as the image. Why? Because maximum value is 1 by 2 root 2, minimum value is 0. 1 by 3 lies between 0 to 1 by 2 root 2. Okay, na? So by seeing this also we can guess that this second statement is right. If first statement is right, second statement is also right. Okay, so both statements are right. Both statements are right. Okay, now, so this was a problem given, a very, very nice problem this is. I hope that you understand this solution. So dear students, so today's class, I hope that you enjoyed. With some more problems and some more concepts in the next class, I will stand before you. Until then, all the best.